Stig, tell us about the engine vibrations and limitations for dispatch. Oh, wow, this is a really good question. And I'm sorry to tell you, I can't give you a really quick answer, so buckle up, another long one. All aircraft engines, whether it be a reciprocating engine or propeller, a turboprop, or a high bypass engine such as this, all have vibration. You think you have that much amount of power and force going through, you're not going to have any kind of vibration? Guess what? You are. And that is completely normal for these type of engines. For now, we're going to stick to the high bypass engines. As a flying passenger, you probably will never ever even notice vibration through the engines. You will hear the noise, you will hear the hum, but you won't ever feel true vibration from the engine. But it is monitored. Just a brief understanding on the engines themselves, they don't directly connect to the wing. They actually go through a pylon. The wing is connected to the pylon connects to the engine. Or the other way around, whichever way you want to look at it. It's basically like a car motor mount, just like your vehicle's engine. Like this, your car has motor mounts. And just like your car engine right there, that also vibrates very much as well. So now you ask yourself, how do you actually even measure engine vibration? Well, nowadays, modern engines have very sophisticated equipment. They have engine vibration sensors, as well as computers to monitor them. Since most engines are dual shaft, which includes the N1 and the N2, you're going to have dual sensing elements. These elements are directly connected to the casing of the engine. The sensors themselves are two transducers, piezoelectric accelerometers, usually located in their respective position for N1 and N2 bearing support. Remember, these shafts ride on bearings. The sensors include a stacked disc placed between a mass and a base. When the accelerometer is subjected to vibration, the mass extends a variable force to the disc. This generates a potential difference directly proportional to the accelerometer and then sending a frequency range. This is what sends the information to the flight deck. Well, to the computer, then to the flight deck. Now, how do you actually analyze this data? Engine vibration is analyzed through IPS, inches per second. Obviously, the higher the value, the higher the vibration. Pilots and maintenance are trained to monitor this. We also have manuals to tell us when it exceeds the vibration limits. There's a range of acceptable limitations when it comes down to vibration of an engine. Let's put it in the scope of good, fair, slightly rough, very rough, and dangerous. Obviously, we do not ever want to see dangerous. But taking everything else into consideration when the engine is running and the amount of forces that it's going through, there are acceptable limits to engine vibration. So now we come to the actual question of what causes the engine vibration. Simple fact, imbalance. Just like with any kind of centrifugal force, if you introduce imbalance, you are going to encounter vibration. You have components that are rotating at extreme RPMs. A slight imbalance in that will cause a vibration. This is why I always tell you, the engines are perfectly balanced. Everything from the core up to the fan blades. This is why you always see the engine windmilling freely in the wind. But there are outside factors that could cause engine vibration and imbalance issues. The bigger the object is that is spinning at high rate is the most suspect. Guess what? The fan blades. These bad boys. This video is courtesy of Fixed Fly Travel. She actually got to attain a very lovely CFM 56 blade right there. It was a decommissioned blade and it's out of service, but it's a very good showcase to show you on how these blades actually look outside of the engine and what it looks like when it's damaged. As you can see, the aerodynamic properties of this blade has been completely obscured. It is no longer suitable for the engine, so it's been decommissioned. But it's something like this that could cause a massive imbalance in an engine. Whether it be outside sources of damage such as FOD or bird strikes, various amounts of ingestion, blades over time get deteriorated. Matter of fact, blades over time do wear out, which causes them to go off of balance. You also have to take in consideration the internal portions of the engine. This is when I talk about the compressor section, the low pressure turbine and the high pressure turbine. These things also have blades and they also take wear and tear. There's debris and coking that gets accumulated on top of the engine blades themselves internally, as well as wear and tear on the shafts and the bearings that these blades and discs ride on. Over time, these bearings and shafts also get deteriorated, which causes it to wobble, obviously causing more vibration. But once again, all of this is monitored. All of this is paid attention to. If the engine exceeds its vibration values, it will be taken out of service, and the engine will be basically torn apart and rebuilt. But before any of that even occurs, all of this is monitored. Flight deck gets the information properly, as you can see right here. Watch closely. You see that where it says vibe N1, N2? It's constantly showing the pilots and maintenance personnel what's happening with the engine when it's running. So if it exceeds any kind of limitations, trust me, we're going to know about it, and it's going to get documented and reported and fixed. As I mentioned earlier, the most common problem or the most common issue of why an engine vibrates is its biggest portion of its rotating surface, which is the fan blades. And this is where maintenance comes into play. That's right, we can remove the fan blades completely. There is a procedure within maintenance where we call a blade lube. Basically, we take apart the fan blades and take them all out, and we re-lubricate all of those crevices. Not only do we re-lubricate it, but we also inspect it, making sure there is no damage anywhere to be found. This prevents vibration. This is why we do this procedure. Applying new lubricant and sealing those crevices helps lessen the vibration. On top of that, the blade roots themselves also get re-lubricated. Well, first of all, cleaned off, inspected, then re-lubricated. The engine that you're looking at right now is the CFM 56-5B. This is equipped on the Airbus. But there's also other tasks we do. If there's internal damage to the engine, we have the capability of borescoping it. It's basically a miniature camera that we can push the camera probe into the core of the engine and take a look at the specific blades and making sure there's no deterioration and no damage. There are a variety of engine plugs that we can remove while inspection department comes over with their specialized tooling and inspect the engine. If there's any kind of discrepancy that is found, cracks, nicks, dents, or coking within them, we will address the situation, whether taking the engine completely out of service and put it in a brand new engine, or making sure that it's within limitations and it's acceptable for service for a prolonged amount of time. But this is what we do. This is why we are here, and this is what aircraft maintenance is. We ensure your safety, and we ensure the safety of the aircraft. I hope this helped answer that question, because I know this was a long one. Thank you everybody for watching. I appreciate you, and I will see you on the next one. Take care. Later.